Good morning, friends. We are going to discuss the next part from our previous class. As we all know, the last class we were dealing with the DNA packaging. So we are going to deal with another topic from the same chapter, that is genetics, that is DNA replication. It's a huge thing, so we are breaking the whole thing in some different videos. So first we are going to deal with the basic enzymes that is being involved in the process of DNA replication. But before going to the enzymes, you must at least know, as you have seen the term, what is replication means. You all know what is DNA, and replication means simply Xerox. So if you want Xerox copy of something, you need the original piece. So the original piece for us will be the DNA molecule from the parent cell, okay? And from that cell, when cell division is going to occur, and at the end we are going to have two new cells. One copy of the DNA molecule will be carried to each one, and the newly synthesized will be present along with this. So how this new strain came with this one, or how this strand came with this one, is our aim of studying replication. Okay? So in this replication process, we have to consider the first enzyme as helicase. So what does helicase do? It unwinds the DNA molecule. As we all know, if we have a better structure of DNA, it will be like this. So it's in a helix fashion. So this strand have to copy one strand side by side, this one, and one new strand will be coming this way. But as we all know, both these strands are joined by some hydrogen bonds. So before going to add new strand, what we have to do? We have to remove these bonds and make it separate. So for separation of the helix, the first enzyme comes to play. Here it is helicase. Second thing, if we have to start the process, we need a primer. We need a very important term, that is primer. So simply, it's a single-stranded RNA molecule where it provides the free 3' hydroxyl end for new nucleotides to be added. What is this one? So when this strand will be opened up by the enzyme helicase, that means when this helicase enzyme will move this way, it will open this much of its stretch. So what we'll have to do, we'll have to add new strand here, we'll have to add new strand here. So for new strand to occur, we need some building blocks. So my building blocks are nothing but the nucleotides, but nucleotides cannot be added if it doesn't get a free 3' hydroxyl end. So this is very important, and this is going to be provided by the primer. And the primer will be synthesized by the enzyme primase. Okay? So if we have some ends, like this is 5', 3', this is 3', 5', what will occur? That the primase enzyme is going to sit a primer in the end, and this primer is going to provide the free 3' hydroxyl end for new nucleotides to be added. Next thing, the enzyme topoisomerase. So if you imagine a flexible wire, and if you try to open it with your hand, what you will see? The point where it is being opening, farther to that point, there will be much more coiling than the normal part, because if you are putting a tension in this side, the tension will be exerted on the other end, and there will be a more complicated structure that we call as DNA supercoiling. To remove that supercoiling so that this can move this wards, and so that the supercoiling position in this side, as you are having more tension in this side, there will be more complex structure here. So to remove this complex structure, here comes the enzyme topoisomerase. What it does, so you imagine the flexible wire, when it is being in a supercoiled position, topoisomerase 1, what it can do, it can cut one strand and swivel both the two ends and again join on the other side. By doing once at a time, it can remove the coiling once at a time. At the same time, there is another enzyme, that is topoisomerase 2. This is a more simpler one. What it does, this enzyme cuts both the strands and make the tension release and again joins. That means topoisomerase 1 to 2, the difference is that it cuts one strand at a time, and this cuts both the two strands at a time and join simultaneously. The second thing, the another enzyme, that is single stranded binding protein. This is simply also known as SSB protein. So what it does, see, suppose we know that it was adenine, it was thymine. By using this enzyme, this 2 earlier was bound by 2 hydrogen bonds, but we made it separate now. But as we made this happen by an enzyme, but this had affinity for each other, so they may again join to have forming the bonds again, but we do not want that to occur. So what we will do, not we actually, what the system does is that it appoints another protein on the outer sides of the DNA molecule. Those are my single stranded binding protein. What it does, it doesn't allow to bind the separated nucleotides again, because we need new DNA molecule, new DNA strand by this side. That is what the single stranded binding protein is going to do. The next thing is my DNA polymerase enzyme. So this is the most important thing you can imagine. It's like it's the basic machinery. Polymerase is coming from the term polymer. That means, what is polymer? Suppose this is a singular unit and you are adding the same things again and again and make a complex of singular unit, repetition of the singular unit, that whole structure we call as polymer. So this structure will be synthesized by the enzyme polymerase. What it does, it adds these building blocks one by one in this fashion. So simply you can imagine, suppose this is my old DNA strand, this is the one, and suppose this is the primer and this is the primase. So not primase, this is the primer. So this hand, this minus hand is suppose this one, DNA polymerase enzyme. What it will do, it will add one nucleotide at a time and again bring one and will add this one. So this hand is actually the DNA polymerase enzyme who is responsible for adding nucleotides one in a direction one by one. Again, you will find different polymerase enzymes in different conditions. The most prominent you are going to deal with your secondary syllabus is DNA polymerase 3 followed by DNA polymerase 1. So there are some differences between these two. We will take some different classes for this one, but simply this DNA polymerase 3 is basically responsible for polymerase activity, but DNA polymerase 1 have another significant feature. What it does, it can replace the primer by nucleotide, basically deoxyribonucleotide, DNTPs, to make the whole molecule DNA at a later time. See, it was earlier, this part was RNA and we added DNA once at a time in this fashion. But when the whole molecules will be synthesized, this cannot be remain as RNA because this strand was DNA, we are adding DNTPs, so both the two strands must have to be DNA. But this was not DNA, so this RNA will be replaced by the enzyme DNA polymerase. And ligase is nothing but it's also it's related to your first year syllabus. We studied in the enzyme portion that if we need to join two molecules, we add ligase enzyme. So ligase or DNA ligase, what will do? So wherever there will be, suppose this is a stretch where this is a nucleotide, this is a nucleotide, where you have to add these two without polymerase, this is going to be done by the enzyme ligase, and this is almost the basic enzymes. We have to deal with the DNA replication chapter or DNA replication topic, and if there is something else we are going to discuss side by side in the replication process itself.